Welcome to all of you in Quantum Mechanics lecture series. Myself, Dr. Arvind Sharma, Professor in Physics, Govt Lohia College, Churu. Today's lecture is on variational method in quantum mechanics. This method is also known as variation Rayleigh-Ritz method. There are many quantum mechanics problems which are not convenient to solve either by direct solution of wave equation or by using perturbation theory. In such kind of problems, there is a well-known problem of helium atom. No direct method of solving the wave equation has been found for this atom. And if we are trying to use the perturbation theory, then it is also gives unsatisfactory results because first order approximation is not accurate enough. If we are trying to solve the helium atom problem by using the perturbation theory, then first order approximation is not accurate enough. While it is troublesome to calculate the higher order approximations, if we are trying to calculate the or solve for higher order approximations, the calculations are very tedious. Okay. Now, for this problem or for this region, an approximate method is used in many problems, which is known as variation method. And what is variation method? In variation method, it can be extended to the state of the system. It is an approximate method and it can also be extended to the state of the system other than lowest one. Basically, variation method is especially used in chemical problems, that means in physical chemistry, but it is well-known method in physical problems, that means in physics also. The variation method may also be applied to the lowest state of the given resultant angular momentum. Lowest state of the given resultant angular momentum and for the given electron spin multiplicity. So now let us start variation method. First of all, we know that the expectation value of energy in normalized state function, suppose function is psi, it is a well-known expression, expectation value of E equals to integral psi star h psi d2. d2 is volume integral. Suppose we choose the wave function psi as a variable function. Here we are choosing wave function psi as a variable function. Then integral or equation 1 is known as variational integral. Varianced integral. And it gives the upper limit to the energy E0 of the lowest state of the system. When we solve this relation, then what we get, upper limit to the energy E0. And what is energy E0? Lowest state of the system. System's lowest state, and the result is E greater than E0. The function psi is the variation function. What is psi? Psi is the variation function and its choice may be quite arbitrary. When we are choosing the wave function, it is arbitrary. but more wisely, it is chosen such that E approaches more closely to E0. The trial function or variation function is choosing using the arbitrary method, but our aim is that the trial function or variation function should be like that, or such kind of function that the result E approaches the more closely to ground state energy EC. Okay, that is the point to be noted. Now, if the variation function psi equals the function psi 0 of the lowest state, suppose the chosen or trial wave function psi is equal to psi 0 lowest state. In that case, expectation value of E equal to E0, that means E is equal to E0. But if psi not equal to psi 0, the case where psi is not equal to psi 0, in that case, we are using expansion theorem for psi. What we are using? Expansion theorem psi, and it expanded in terms of a complete set of orthonormal functions. Psi is expanded in complete set of orthonormal functions, and orthonormal functions are here we are choosing phi 0, phi 1, phi 2, phi n. So what we are doing here, we are expanding psi in terms of phi functions, and psi equal to summation n an phi n, where summation an star equal to 1, and equation, well-known equation, Schrodinger equation h phi n equal to en phi n, where en is eigenvalue of this equation. Now, substitute this in equation 1. We just substitute value of psi here. Okay, and after substituting summation expectation value of E equal to summation n an star am phi n star h phi n. Here we are using two different wave functions. One is phi n and second is phi n. That means psi n and psi n. Psi n equal to summation an phi n, and psi m equal to summation am phi n. So here are two different constants and two different wave functions. H phi m. H phi m equal to em phi m. Now, replacing this here, this term becomes em phi m. Em is eigenvalue, and it can be taken outside the integral, and this integral part becomes delta n, well-known Kronecker delta function. So this equation becomes expectation value of E equal to summation n en star am en. Okay, and you are familiar with Kronecker delta function. Delta mn equal to 1 if m equal to n, and if m is not equal to n, then its value is 0. So our value for expectation value of E, we got summation en modulus of an square en. Okay. Subtracting ground state energy. We are just subtracting ground state energy from both sides. So equation becomes expectation value of E minus E0 equal to summation n modulus of an square En minus E0. As we know that because this is a modulus and it has positive value, an square is positive, and if an square is positive, then En is always greater than or equal to E0. En always greater than E0 for all values of n. Therefore, right hand side is positive. Right hand side is positive or 0. Right hand side is positive or 0. Hence, we proved that expectation value of E is always an upper limit of E. Expectation value of E is always upper limit to E0. That is, expectation value of E is always greater than or equal to E0. That is the main idea of this method. Now, this theorem is the basis of variation method. This theorem is basis of variation method. Now, for calculation of appropriate eigenvalue of the system, theorem is basis of variation method, and what we are calculating appropriate eigenvalue of the system. Now, suppose we choose number of wave functions. Suppose we choose the number of wave functions psi1 to psi3 up to psi n. Then we can calculate the values of corresponding eigenvalues which are E1, E2, E3, so on, corresponding to them. And each of these values of E, all these values of E is greater than the ground state energy E0. The lowest one is the nearest to E0. Which is the lowest? That is nearest to E0 from these eigenvalues. Okay. Now, many times functions psi1, psi2, psi3 are only distinguished by having different values of some parameter. Suppose there is some parameter lambda, and for different values of lambda, that means functions are depending on that parameter. Psi is function of lambda. So functions are only distinguished by having different values of lambda. Okay. The process of minimizing E with respect to this parameter function is depends upon the parameter lambda, and by the process minimizing E with respect to this parameter lambda then be carried out in order to obtain best approximation to E0, which from the trial function psi. Function psi is known as trial function or variation function, which we are using here in this method. And trial function is chosen that it involves the variation parameter, which may be considerably okay. Now, in the case of helium atom, this method has been applied with great success. The problem of helium atom, it is very good method for such kind of problems. Now, if function psi is not normalized. Suppose that function psi is not normalized, then expectation value is given by two terms, numerator and denominator. In bracket notation, bra psi h ket psi upon bra psi ket psi, or in integral form, it is given by integral psi star s psi d2 upon integral psi star psi d2. Okay, evaluating integral on the right hand side. How we can how we can calculate right hand side? Just put the value of trial function here and calculate the integral. So you can easily calculate the expectation value of E that depends upon number of parameters. That depends upon number of parameters, and varying these parameters until the expectation value of the energy is minimum. What we are doing? We are calculating the expectation value for different values of parameter until the expectation value of energy is minimum. That is, our aim is that the value of expectation value is very close to the easy. Then that are the good solutions for such kind of problem. Okay. E lambda 1, E lambda 2, lambda n equal to bra psi lambda 1, lambda 2, lambda n, h ket psi lambda 1, lambda 2, lambda n upon bra psi and ket psi. This equation is written in bracket notation. Okay, and these parameters, actually parameter lambda is such that the expectation value of the energy takes a value. For minimization, delta E upon delta lambda n equal to 0. Delta E upon delta lambda 1, delta E upon delta lambda 2, delta E upon delta lambda n equal to 0. So these are the fundamental basics for variational method. Okay. So in this lecture, we just learn about the variation method technique, and my lecture series is strictly according to the syllabus of MGSU University, Bikaner, for MSc semester second students, and all students are advised to read minimum one book. You can read more than one book, but you just go for minimum one book to enhance your knowledge. Don't try to read only modules or DOMs, because books are most necessary to enhance your knowledge. You can go for any kind of book, because book is book and notes or modules are modules. Because in books, the knowledge is completely given in conceptual form or statement form or mathematical form. You can use here for quantum mechanics part for MSc second semester, quantum mechanics by L.I. Siv, quantum mechanics by Powell and Brisbane, quantum mechanics by Venkatesh and Matthews, quantum mechanics by J.J. Sakurai. There are many kinds of books. Okay, it doesn't matter which book you want to follow. If any kind of book you think that is useful for you, or you are understanding the language of that book, because when you go through, suppose you are just taken in one topic or one article and just read that article from 5 to 6 minutes, then you easily understand that 80 to 90% material is equivalent in all books. in few books mathematics given more, in some books concepts are given more. So it's better to use 2 or 3 books for your conceptual or mathematical enhancement. Okay, thanks to all of you.